Hosting this, and thanks everyone for coming out. As promised, we're gonna go through some of Clojure's data science stack. So there's a little overview here. So this is my editor, obviously, and then I'll be like rendering things as I go in this notebook. As is a total side note, but I'm using Clay, which is one of the many notebook tools. So anyway, just briefly to start, we're going to go over basically filling these things out. So a little bit of this sort of maybe lesser known or maybe slightly more like the realistic types of things that you might end up having to do in sort of like a real world project. So I'll just dive right in. There's a lot to cover. And yeah, it's just sort of like a live, pseudo live. I have it's like a technically prepared notebook, but we'll go through it and I'll explain everything as we go. So yeah, so basically we'll just dive in. There's a housing data set. Yeah, that has, we can see it here, but oh, my screen is really big. Some information about like different properties of houses and their sale prices. So basically we're gonna just kind of go through like an example like analysis process of how you might explore this and how you might sort of model the housing prices or maybe predict them based on certain things. So yeah, so this is tablecloth TC, and this is the main sort of like library that most people know. We can explore the data set a little bit, checking out what's in here. So this one has like a ton of columns. These are all different things, excuse me, that are potentially relevant in sort of guessing the sale price. So we'll sort of dive in and start to like clean up the data and process it a little bit. The first thing, so for reference too, I should mention this, this data set and this, like the idea for this analysis comes from a paper, which is kind of like a project that ended up getting hosted on Kaggle. So Kaggle is like a not all machine learning, but it's like a data science platform that hosts like tutorials and competitions and all this kind of stuff. So most of the data sets for this workshop came from Kaggle, and some of the ideas for the analysis from there as well. So yeah, so first thing I want to do is just plot this data. Looking in here, it's not exactly obvious, but I'll tell you that the I'm going to sort these because they're hard to see. So this grand living area is the sort of total living area, and that information is available in the where the data set comes from. So this is like just to get a general idea of how, like what this data looks like. We'll just throw it into like a simple scatter plot. So this is one of the things that I mentioned is like very much in flux. So one of the big projects that we're working on this year is sort of tightening up the data visualization story in Clojure. So this API is like very, very new, as in like a few days, and very experimental, but it's an example of the direction we're headed. So most people know right now the current data visualization story in Clojure is basically like various wrappers over JavaScript libraries. And what we're aiming to do is to build a grammar of graphics like API to accomplish this stuff. So it'll look something like this. So this is not necessarily like final. It's not really complete yet, but the idea is to work with this kind of data. So here we can see this plot. So this is the sale price versus the living area. And in the paper, they say basically to avoid messing up your analysis, we're just going to cut out these 4 outliers that are houses above 4,000 square feet. Obviously, if you're a data scientist in the real world, you might be like, don't cut out the outliers. You should come up with a model that actually works with outliers. And that's probably true. But for the sake of demonstration and the sake of this experiment, and this is the real thing. So I'll stop rambling so much and get on with the talk in a second. But there's a lot of caveats at first. So another one is like, I'll basically today I'm going to just go over a lot of like how to do things in Clojure, how to accomplish certain tasks. But if you were doing like a real analysis, there's a lot of work that goes on in data analysis before you ever even write code. Like, so you want to understand the data set before you really even dive into analyzing it. And then this is more about like, once you get to that point and once you understand what you're working with, how would you do that in Clojure? And so, I mean, obviously sometimes you need to kind of play around with it to learn about it. But yeah, anyway, in this case, you know, say there's a reason we know that you want to drop these ones. So in tablecloth, it's just as simple as this. We'll select the ones that we want. So anything bigger than 4,000 square feet. Oh my gosh. And then we can do our same plot here. And then this is going to leave us with this data set. So this I'm going to bind to this bar so that I can just work with this data set without the outliers. Oops, I don't want the plots. Perfect. So I'm also, sorry, I'm just looking at my notes here. I'm also going to drop the ID column. So if we look at this list of columns, this ID one is just like a row index kind of thing. And so that's not going to be useful in modeling this data set. So I will drop this. And so now we've got our outliers sorted out, and we'll jump into some like basic pre-processing stuff. So the goal basically is to like model this, build a regression model, like a linear regression model that can predict the sale price. So before we go into that, basically there's all these processing steps. So first, yeah, we'll get the ones that have missing values. So I guess I'll do that down here. This is always a pain when you work with real world data. There's always going to be like a ton of messy data and missing values. We can see, so we can like check which ones have missing values if we do this kind of thing. Tablecloth comes with a useful kind of like summary helper here. So this is like just an overview of the data set. So we've got like the data types, the number of missing values, and all this. And so we can get the rows that have oops. Is that gonna work? Yes. So these are the rows that have like any missing values. And so if I do this, then now we have a list of these ones. So these are the ones that we have to deal with. One easy way is to just remove them. But again, this is like where it comes into understanding your data set. So you might, if you're the data scientist, look at this list and be like, I don't really care about any of these. We'll drop this one, drop that one. The other thing that you would want to do is like actually look at some of these columns and like figure out what do you replace the missing values with. Like some of them are, like this basement quality is encoded, there's some values here. So like, what does a missing value represent? So that's the kind of stuff that is more like, that would be more like a data science tutorial. And that's the kind of thing I'm just going to like take for granted here. And just in the interest of time, I'm going to show you this. So, oops. So basically in this case, what we're going to do is replace the missing values from lot frontage and the veneer area with 0. So we'll assume if there's a missing value for lot frontage, that means there is none. The missing values for these two, so the veneer type and alley, will be none. Here it's no. And then we are going to drop there's one row that is missing a value for electrical, and then that one we will drop. So again, this is the kind of thing, this is like, I'm like skipping a lot of background stuff. This is just to basically demonstrate, like, once you've done that analysis, so basically this would be like going through the data sources and where did this data come from, and what do the values in these columns represent, and all those kinds of questions. And those are just questions that you have to answer, like about the data. Oops. So anyway, once we have that, oops. And so I guess, and for context, like, we do this because our models, so the models that we're going to train on this data, are just like basic regression models. Everything has to be a number. So you can't deal with strings. We can't deal with missing values. And that brings us to the next thing, which is converting any string columns to numbers. So this is a thing that is cool and built in. And this is, again, so, okay, one thing at a time. First, we can get the names of the string columns. So we'll take our data set that's updated here. So there's lots of ways to work with data. I tend to do this, like, kind of bind the resulting, like, sort of updated data set to like a new var as I go, just so I don't have to copy paste like all of the steps every time. But if you were doing this for real, you probably just have like one big pipeline, because you might not be doing this as many times. But anyway, yeah, this way it's like I know I'm starting from here basically. So I've already got the outliers taken care of, and then I've already got the missing values taken care of. And so now I'm going to just get the string rows. So data type. So if we do this, this is going to give us just a subset of the rows that have the string type. And then so I can get just a list of those by grabbing the column name, column. Oh, come on. There. So this is the list of columns that are not numbers. And so what we can do is take advantage of tech.ml.datasets helpers here. So this this comes from tech.ml.dataset, converts the numbers into numerical representation. And really, so this is another thing. This is not exactly complete. So in order to do this properly, you need to sort of map the strings to numbers. So it's like for every value you have, like type 1, type 2, type 3, whatever, as the values in your column. You're gonna make a little map, a sort of legend that says like, okay, 1 corresponds to this string, a 2 corresponds to that string, and 3 corresponds to that string. And then you're gonna have to unwind that mapping in your final analysis. So just, yeah, again, in the interest of time, there's a lot of stuff I want to cover today. going to like assume that that work is done. And then once you get to the point where you have your mapping, point being, you can use these helpers. And there's a lot of great stuff in tech.ml.dataset. So we'll see at the end, yeah, the sort of all of the different sort of parts that we touch on. But anyway, yeah. Again, like with some shortcuts, this is basically how you would do it. So now we have this data set that is all numbers. And again, this is not strictly complete and not necessarily, and maybe, you know, missing some steps, but in terms of the implementation, this is what it would look like, more or less. So we'll save that. I say save, but you know what I mean, bind it, whatever. So that we can look at some combinations of features. So this is something you might do if you were looking for I don't know, different types of so when you're looking for relationships between variables in a data set, there's lots of different approaches to take. One of them is to check the sort of correlation between the target column that you're trying to predict and some of the features that you have available. And then you can try to like engineer combinations of features to better model your data. And so as a starting point, you can inspect the correlations that are available. So this is another namespace from tech.ml.dataset, which is the underlying library behind tablecloth. So this is already implemented for us, and it's going to return a really cool giant list of things. So basically, this is like the correlation between like every variable and every other variable. So we don't care about all of these at all. I really only want the sale price one. So this is the correlation between every variable and sale price. And so I'm gonna I'm just gonna organize this a little bit better so we can take this. This is a little bit messy, but anyway, sort by second. Okay, so yeah, so we've got this. We don't need all of these. Take like 30 of them. So yeah, so here we can see like the overall quality of the house is highly correlated with the sale price, the living area, the number, like the size of the garage, all this stuff makes sense. But then in our sort of like higher level analysis of the data set, we might be like, yeah, okay, like I know what a house is, I know what real estate is. Like I might be able to guess that there are other combinations of these variables that are better correlated with the sale price. And so this is where we can start to sort of engineer some features. So I will take, so for example, we've got, like, what do we have? Overall quality and the overall condition are not here, right? So we've got like this, and then, or maybe down here, we've got like garage quality and garage condition. So what we can do is like basically simplify this list by combining some of these. So again, this is the kind of stuff that's more like picking those out and doing that level of analysis is like a data science class. But for this Clojure class, we'll just see how to implement it. So if we want to compute like an overall grade, Tablecloth has this API for mapping columns. So we give it the name of the new column we want, the list of the old columns that we want to use, which is this, and overall quality. and then a way to combine them. And so this is the first time we'll see this again a few more times in this walkthrough. But this TCC thing is the new tablecloth columns API. So this is basically like a implementation. Again, it's implemented in underlying like dtype next, but basically it's a sort of much nicer, like much more elegant API for working with columns and tablecloths. So this is going to say, this is equivalent basically. So this map columns thing takes a function that passes these two columns or as many columns as you specify in here. And then you can use it like this. So obviously you guys know that if we do like our select column here, yeah, so this is now like a combination of the overall condition and the overall quality. And obviously this is the same as just this. And so that's what we'll use. And there's a bunch of these. So I'm gonna, just to save time, copy them from my place, my secret working notebook. So here there are a bunch of combinations. So we can combine, these ones are all basically that same idea. We're just combining the like two attributes about a certain thing into like an overall score. So like the size of the garage and the quality of the garage and the area of the pool and the quality of the pool. But then there are a couple other ones. So like the total number of bathrooms, for example. So there's like in the data set, it's all split up by like full basement or full bathroom in the basement, half bath in the basement, so on. Here, this is like a spelled out like usage of tablecloth columns. So again, this is so much more elegant. I won't get into it today, but like there's lots of talks out there about working with columns and how you would have done this before is just much more verbose. So this is, I should give a shout out to Ethan Miller, who mostly worked on this among lots of other people, obviously, but he was sort of the lead on this project for the last little while. And this was also funded by Clojures together. So I know it looks like a small thing, but it's actually super nice. So yeah, so this way, this allows us to just add these all together. So we've got the full bath count, half of the half bath count, and so on. So we can get like a total bath count. Here's the total square footage, including the basement. This is the total upstairs square footage of the house. And this is the total porch size. So if we do this, we'll get this data set now with lots of extra columns here at the end. And then we can check the correlations again. So again, reminder, these were the sort of relationships between the variables we had and the sale price. And then if we do this same kind of thing, I'm gonna bind this to something. So yeah, if we save this, oops, and we check these, now we can see like a lot of our engineered ones are up here. So the overall, oh, that was already there. The overall grade is the one. But yeah, like the total square footage is the main thing, or like the highest correlation with the sale price, which makes sense. The total inside square footage makes sense. The total bath count is here. So, and here's the overall grade. So like a lot of our engineered features are now like in the top 10. And so obviously, that's the work of a skilled data scientist, not me. But the idea anyway is to pre-process your data in such a way that you're going to like get the best model. And the the features that predict your target the best might not necessarily be the ones that you're given, but you can sort of play around with the data and see what you have. And so this leads us to higher order combinations. And so this is just a way, it's a very similar kind of idea. If we drop the first one of these because we don't want the sale price one, and then take like just the top 10. Oh, what did I do? Oh, right. Sorry, too much talking. Yeah, let's see. Okay, so I guess I'm gonna save, no, okay, it's all good. It's always, this is the thing about functional data science, is like you end up, it's way better, don't get me wrong, it's way better that like you're not dealing with these mutable objects as you go through, but it does means like there's a whole world of like schools of thought around like how do you keep track of this state, because some of this stuff, like if you're training a model, for example, that's state, the model is trained and now you want to use it later. And so anyway, there's lots of different approaches, and that's a whole other rabbit hole. But yeah, but anyway, it's interesting. So if we do this, we take, oh yeah, I want to drop the sale price one. So this is gonna leave us with this. So these are the top 10 most correlated features to the sale price. So you can do higher order combinations, so polynomial combinations of these pretty easily. So we will take the first one that's going to give us just the column names. And this is, I guess, this is worth mentioning too, if you're here and like not super used to working in Clojure, or not necessarily used to working like with a REPL, this is how I recommend working with it. So whether you're sending these to a notebook or to a REPL, it's like the same idea in this case. The nice thing about the notebook is that it kind of formats like charts and tables and stuff a little bit nicer, but it's the same workflow of like change something, see it in the REPL, change something, see it in the REPL. And it's just a great way to work. So if we can reduce these over, I wrote this down because I'm obviously going to mess it up if I try to do it live. But yeah, so basically we want to just make higher order combinations of these specific columns. Excuse me. So we take this is our new column that we want. And we'll just take the one, and then for the first thing, we'll square it. Here we can cube it. So this is, there's not a default helper for cubed, but we can do this power, yes. So this is like a proposal I would maybe make to pass the number first. But anyway, there's this, and then there's a square root one that we can do. So that's going to give us, what am I missing? Right. We'll start with our data set. So this is an example for like where I like notebooks over the REPL. Like this is obviously a mess, and there's discussions ongoing again about like, you know, changing the way that very wide data sets are viewed in the REPL. Like technically this is formatted, but it's obviously not super easy to read. So if you send it to a notebook though, you'll get this kind of thing. And now we can see we've got our all kinds of stuff going on in here. So we can we can check these again. If I say this is with polynomial combinations, no, I didn't. So yeah, so I guess you can't see because I'm not showing you the REPL, but I am sending this to like this now. You have to like sort of register it with the REPL or send it to the REPL. Obviously, or else it won't work. So now it's there, and now we can check this. And now we can see like, this isn't that surprising. These are like our top 10 ones now are all these like these kinds of features. So anyway, there's lots of other types of like feature engineering stuff that you can do. This is just an example of like a couple common techniques or approaches and how you can like verify that it's working. And yeah, just to keep things moving, we're gonna jump ahead into modeling this. So like now using these features to train a model and make some predictions. But yeah, this is the area of the whole stack that I would say is like the most mature and the most stable. This has been developed over the past like 5 years. This exact example actually is taken from, well, I guess, yeah, originally from a Kaggle competition. But there's a notebook that exists out there that I could share in the chat after by Chris Nurnberger, who implemented this basically exact same thing in Clojure, like I think almost exactly 5 years ago, actually. So it's really fun to see like how the ecosystem has evolved since then, and how much easier it is to do now. So yeah, it's cool. We've made a lot of progress. But yeah, anyway, this next, I would say from here on, we'll start looking at some of the machine learning stuff, some of the a little bit more of the visualization stuff, and that stuff is slightly less mature. It's not. It's kind of yeah, I would just say like still under active development. Whereas the data wrangling stuff and all of this like table manipulation stuff is very solid, and I would 100% recommend using it. Although I understand that it's not like it's. You got to have a full stack. You can't just be like, oh, use tablecloth because it's super stable, but don't worry about too much of like the visualization side. It's like it kind of all comes as a package deal. But anyway, yeah, moving on. So this is a whole thing. There are lots of ways to do sort of machine learning stuff in Clojure. I'm going to show one of the ways that's like very verbose and explicit today, just so I can explain as I'm going what's going on. But if you were doing this all the time and you're looking at this thinking like, wow, that's a lot of lines, there are libraries and tools out there that kind of automate away or abstract away some of these steps. It's just that there are lots of different workflows and lots of different ways of doing machine learning, I guess you could say, and that has led to lots of different ways of accomplishing the same thing. And so yeah, so today we'll look at one example that is like very explicit, so I can explain as I go, but keeping in mind there are other ways as well. So this is just I just found this a little bit verbose. So this is just the options for a regression model from the Trivio library. So Trivio is a JVM, like a pure Java machine learning library that has a bunch of models implemented in Java. Then there's also, I'm going to have to import a couple of things. Yes. And I think more, but anyway, yeah, so just, again, for the sake of demonstration, we'll look at 3 models. So there's the Trivio card, so this is classification and regression tree. a random forest, and this is another one that works. So this is the thing. This is what I mean, where it starts to get a little bit less polished, a little bit less complete. Smile is another Java machine learning library that is like sort of being phased out of the Clojure ecosystem, partly because it doesn't work on M1 MacBooks. So you can make it work by running an x86 JVM, but that's annoying because that causes other problems with other libraries, and especially Python interop, which is why I couldn't use it for this one. But I shouldn't say Smile doesn't work on M1 Macs. Some of the algorithms that it uses don't work. And then there's also some conversation about GPL licensing and stuff like that. So broadly speaking, I would say people are switching to primarily use Trivio, which does implement like more or less anything you could ever want. And then there are some more basic models from just like Apache libraries that are in use as well. So yeah, so anyway, moving on. For today, we'll look at these 3 types of models. These are just 3 random different implementations of linear regression type things. There's one extra step. This is another thing that is kind of abstracted away in many, I shouldn't say most, some libraries that are being developed for working with data in Clojure. But right now, if you want to do this like explicitly, you have to manually set your inference target. So this is telling the model like this is the column we're trying to predict. And then we can train the models. So there's this Metamorph ML library is like the main, where's the train? Anyway, this is not helpful, sorry. Okay, here's the train. So this is basically like the underlying main thing that's actually like running the model or whatever under the hood. And so this is like one of those among the many libraries that, you know, is certainly going to be like a main building block of the ecosystem. So we give it our data set and the model configuration, and we get a bunch of models. So if we look at what this gives us so far, right. Takes like a few seconds, and oh, that's stuck. It's because I forgot to import something. I need this one. Oh, it would be sad if this stopped working right now. Okay, there they are. Please stop. So, okay, this is not useful to show the models, but I'll show you what happens when we use them to predict stuff. Okay, so we have a bunch of trained models. Basically, those, all they look like is just like a pile of numbers and maps and stuff. And if you have like specific, I'm just gonna double check. Okay, specific like evaluation metrics you're looking for, there's some useful information in there. But yeah, for today, for us, I'm gonna carry on and show you how to use these. So to use these to generate predictions, there's another just really succinct, like really nice helper from this Metamorph ML library that's just very intelligently called predict. So same thing, we pass it our data set and then a model, and then here we'll be able to see the results we're looking for. So this is going to give us okay, perfect. This one I think is just actually a little bit slow. Because I ran it too many times. There we go. It's crunching. And so here we've got the sale price predictions using these different models. So this is from, these are just in order, the first, the cart, the random forest, and the gradient tree boost. So you can see those in here probably too. And yeah, there we go. So this is, again, this is like pretty big data set. We didn't need to pass it all like 100 columns or whatever we had. Would have been faster if I filtered out a bunch first, but that's the kind of stuff you can play around with. The idea is just, the idea being like, basically this is how you do it. And then if you want to sort of like compare these, that's like a whole other giant topic I'll mostly skip for today, but there's some basic stats available. So from this is another namespace from the MetamorphML library that help to compute these differences. So this is the average error, something like that. Anyway, you give it, so this, I don't know if you noticed, this returns a tablecloth data set with one column in it. And so that's that. And then we can compare that to our like original values. There's also the mean squared error available. I need to. So there's, so basically, anyway, there's a few things here. Like obviously classification, loss, and accuracy are relevant for classification models. But yeah, this is more or less what you get. I always forget to add the thing to map over. And so I did this in not the smartest way. This is like now training all the models and running all the predictions and computing all of the like metrics. And so here we have some results. And so you can see like these two smile ones are pretty skewed or maybe overfit. But anyway, getting into like tuning these and playing with those would be an interesting topic for another day. But in the interest of time today, I'm going to leave that example there. So this is like kind of wraps up the high level like whirlwind tour of like how do you do ML stuff in Clojure. So again, like every single one of those steps could be like a whole month-long class. But just to like touch on what's possible today, that's basically what we have. So that part of the stack, the ecosystem, I would say is like pretty mature and pretty well established. But I just want to show off with the, maybe whatever, 15, 20 more minutes. We'll see anyway, we'll kind of try to keep it under an hour. The rest of the time anyway, a little bit more about some of the other parts of the stack. So yeah, so to do that, I have a couple other data sets. This one is some information about tunnel traffic. So this is like a common example data set from a tunnel in Switzerland or something. Oh, come on. So here we have just 2 columns, a day and the count of vehicles. So yeah, I guess relevant for this part of the talk is that these are specifically time series things. So there are like 2 types of features that are unique to time series. And I just wanted to kind of like quickly demonstrate how to do those and partly because time series are like a good type of data set or category of data set to use for forecasting and modeling. There's like some interesting types of models that are sort of only relevant for time series. And so, yeah, so if you are used to working with time series data, you will know about time dummies, and that's basically like just a counter. It's like a way to model the sort of progression of time. So in our case, we know we have a time series. Like obviously, that's why I chose this data set. But obviously, if you're going to do these kind of like time series data analysis tricks, you want to first like make sure, and you would do some analysis on this column and make sure like these are in fact monotonically increasing times. Excuse me. In this case, they are. We also know they're already ordered, but I'm just gonna order them explicitly to make sure. This is also just available in tablecloth, super easy. And then to add the time dummy, and again, so this is the time dummy is used so that we can train models, because our models again are it's just all math under the hood, and so you can't do math with like strings or dates. It has to be numbers, and so basically like the whole game, a lot of ML and statistics is like mapping things to numbers. And so for time series, it's really easy because we don't really care so much, depending on what you're doing, about the specific date. We just need to know like the relative day in the data set. And so we can add a column for time that is just the like basically a counter. So it looks like this. So this is how you add a column, and this is how you get the row count of a data set. And so now we have a extra column that has 1 number per thing. And if we wanted to fit a really basic line, there's another type of model that I didn't show with this housing data, because this housing data was a little bit more like complex. But if you just have a really, really basic data set like this and you want to just like fit a line to it, there's a thing built right into dtype next. So dtype next is the underlying library behind tech.ml.dataset, which is the underlying library behind tablecloth. And so kind of there's lots of useful stuff at various levels of this stack. And this is one that is, I'm going to save this. Okay. Yeah, and this is one, anyway, this is one. So this, and we'll give it so basically we just give it X and Y, and it takes columns. So these are like, if I do just this returns a, right. This returns just a column. Well, I'll do it in the REPL so you can see. Anyway, so this is how you can access a column in a tablecloth data set. They sort of have like map semantics to some extent. So yeah, anyway, so this linear regressor thing takes 2 columns, and then we can make a new column using it. I'll call it predictions. In this case, it's more like a model, but this gives us, what have I done? Oh, I didn't give it the data set. This gives us basically our line. So this is how you're going to fit a regression line to some like really basic data. And so this is, this is again a little demo of our like shiny new up and coming API for data viz. So some of this might look familiar. Some of this is based on Hanami, which is this sort of wrapper over Vega Lite that provides this like variable substitution mechanism for like building out plots in data visualizations. I will call this, how about just to keep these straight. So this is more like a proposal at this point, or like a sort of proof of concept, but it's ready enough to show. And so I wanted to show it off today because I think it's a really elegant example. I'll save the width, I guess, and see what we're dealing with of what we're going for. So basically, if you're familiar with the grammar of graphics, which is currently best implemented in R, there's also a Python implementation that's called Plot9. I would argue the sort of like ideal way to do data viz. It depends what you're going for. But anyway, it's the most flexible, it's the most sort of robust, and it's I think the sort of cleanest, like abstract conception of like how to build up graphics. So rather than having like a collection of charts, it allows you to have basically like a language with which to build graphics, and then you can build more or less any graphic, and you're not constrained to the types of charts that your library supports. So that's really what we're going for, and it's kind of based on this idea of like layers and stats. And so I'll show some examples of those. So basically, like we have our base plot here where we give it X and Y. These are incidental, so we have to tell it the type of X or else it won't work. And then we'll tell it to reset the Y scale, or sorry, to not set the Y scale to 0. I'm just going to change these preemptively because I know they're going to look silly. But yeah, so if we do this, we get our plot. And so this is how we want to work with data in terms of visualizing it. It's too loud. Okay. Everything's whatever. Zoomed in. And so here to add our trend line, we just add a line layer and we tell it, in this case, Y is not the number of vehicles, it's the predictions, and then we get our little plot with the line. It's kind of hard to see the line. If I make it look orange, might be able to see it better, or that might be worse. Anyway, that's the idea. So this is what we're going for. Did I misspell? Okay. And yeah, in the interest of showing off this Hanami stuff a little bit more, I'll show one more type of like specific time series feature. So there's another like property of time series that is called lag, and that lets you sort of model serial dependence. So the time plot stuff, the time dummy is like trying to see whether you can predict like a value based on the date that it happened. And here it's like clearly you sort of can. Like if I told you a date in this range, you could give me a rough estimate of the value of the number of cars that pass through the tunnel on that day. And we can do something similar to see whether there's a relationship between the past and the future by adding a lag feature to the time series data set that we have. And so to do that, like functionally, the implementation of that is really just this rolling window kind of feature. So we will do, again, just like making sure everything's ordered sequentially. And then this is another library that comes from tech.ml.dataset, sorry, namespace that comes from tech.ml.dataset. And it's like basically everything's already done for us. So we just tell it, so fixed versus variable. So if the width should stay the same all the way through, or if you have a really wide window, sometimes you want a variable window width so that like the end ones aren't cut off by a significant amount. But anyway, there's different uses. In this case, to add a lag, we will use a fixed window. We'll just take 2 rows at a time, because basically we're just trying to create a data set where one row is like offset from another one by one, if that makes sense. So if not, it will in a second here. So, and then the relative window position, this is important. We want it to be to the left so that we're like scrolling down. And in this case, with just 2 rows, it's not, I guess, as essential, but you want to always take like the sort of the same value, if you know what I mean. Anyway, I'll show you what I mean. So this, and then, okay, so this function from tech.ml.dataset takes a data set, which is the implicit first argument here, some window config stuff, and then a map of reducers. And so there are a bunch implemented already in that namespace, which are the most common ones that you probably want anyway. So in this case, we'll tell it the name of the new column we want. And then this is going to tell it to like always take, so we're dealing with whole rows, and we want to take the first, the value in the first row at this column that I'm about to say. So this is like, this is going to create this data set, which is basically this, this lag thing. So this is an example of the kind of thing that is like, that I'm working on implementing. That's another one of my billion projects that's on the go, is like a collection of utility functions for doing this kind of stuff. So like in our, obviously this is Clojure syntax, but the API would look like, you know, CC lag, maybe like number of vehicles by 1 or something like that. I guess you have to pass it a new column name. But this is the kind of API that I would like to see and that I'm working on developing, so that all of these types of like complicated things, but that are fairly common in some contexts, are as simple as they possibly can be. So anyway, so that's that. And then in this case, if we, so I'm just going to grab this plot config so you don't have to watch me type it all out. And then we can add our points again. There's another thing that we are working on implementing. So part of the grammar of graphics is this kind of like integrated, statistical stuff. So yeah, you can add layers that represent geometries, or you can add layers that represent statistics. And so it's like each geometry has a statistic and vice versa. And in this one is one that works, which is super cool, that Daniel implemented, Daniel Slutsky again. What's going on? Oh, it's refreshing. I'm going to, okay, there we go. So yeah, so this layer is doing a lot of the heavy lifting. So this is doing like basically this, like building this regressor, mapping the column, and then plotting it with this line. So super cool. Oh, this is this stuff. Okay, so couple more quick demos. We can, okay. Yeah, I'm gonna go for it. Another So, okay, so this is how you would do time dummies and legs. So with the, just like simply adding a column and then adding a column using a rolling window. Another big time series thing is trends. And so basically trend is like the slowest moving part of a time series, the long-term change in the average of a series. And so to discover whether you have a trend, one tool that can help you discover whether there is a trend in your data is a moving average. And so this is another thing we can implement with our rolling window. I'm just looking. Yeah, okay. I'm going to grab another new data set here. So this is an example of just some sales in a store. This one is like significantly bigger. So this is a more like realistic example. Like you can see here, we're dealing with about like 3 million rows. We've got an ID, which is just like a column index, some dates, family, which is like a, if we look at family, it's like the list of categories. Oh, my computer's going so slow. These are all very fast when I'm not streaming. But anyway, yeah, so we'll generate a data set that's the average sales in each of these categories. Whoa. What's going on? Sorry, I don't know why VS Codium just tried to open itself. I'm gonna check on the stream. Is everything okay? Okay. All good. Okay, so, right. So I'm gonna show you, this has been covered a lot in other workshops and stuff. So I didn't get like a ton into this like more basic tablecloth usage in this one, but this is, I'll type this out. So this is some of what tablecloth is capable of, and it's pretty fast, as you'll see. So this is like our grouped data set. So we've got now like one sort of sub data set per date. And then if this is another, I just wanted to show this off because it's such a cool usage of the tablecloth columns API. This is something, it was like, again, always possible, but it's so much more elegant now to take the average. So this is all it takes to generate this data set, which is now like we have the average sales of all the families per day. So again, amazing work, Ethan. So yeah, so this is the data set we're going to use for this last little part of the demo to see again. So like the idea is, yeah, you want to see if you might have a trend in your time series. If you do, you can model that with like a time step feature, but it's you don't want to necessarily like jump in and just assume that you have a trend. And so we can sort of try to suss that out. Oh my gosh, I think it's okay. I think I know what's going on. Sorry. I will stop doing that. Yeah, by doing this at this like big average rolling window thing. So this rolling average. So that's going to be this again, and at this time we'll make it a much larger window. So we have days here, so we'll do it like over the course of a year. In this case, we want a variable window because otherwise we're going to have these like really skewed values at the ends of our data set. If you're doing a variable window, you have to tell it which column you're going to use. And then this is also relevant because it's a date column. We want to know that each value is a day. And then also this is important. You have to tell it again to like position the window to the left so that it's like you're starting at the end. And then, so it's going to start out by growing the number of rows, and then it's going to shift, but we're always positioning it like bumping it up as much as possible so that we're using the past values to try to model the future. So you don't want to end up in a situation where you're like trying to model the future based on the past. But anyway, there's just so much stuff to learn. Okay, right. And then we have to give it the sort of like column that we want to aggregate over as we're doing this rolling window thing. And this is another one that's built in to tech.ml.dataset. You can tell it to get the average. And so these helpers, you can write these yourself. It's just, these are way better. Just use these if you can. They're basically like most of the ones you could ever want are there, like first, last, max, mean, min, and sum. So it's like these, and the reason to do this is like these are implemented already in like an ideal way, in a way that's going to be like efficient and work well, and you just don't have to think about it that way. Excuse me. So now we have this trend value. I will grab the, ooh, I did it again. I'm going to grab the Hanami config here just to save a second. Quit this, please. Sorry about that. So yeah, so again, we start with our base plot here. I'm going to kill this width because it's too wide, and then we'll add a layer for the points. That's going to give us this. So this is what our data looks like, just average sales over time. Hopefully that's big enough. And then if we want to add this trend line, we'll just tell it to add a new layer, but using a different Y value. And then we've got this. And so I don't know if that's visible. That's maybe helpful. So there's some weird stuff going on at the front here. Just I'm going to skip that for today for the sake of time. But yeah, so basically this is our moving average over the course of a year. And so from this, you could be like, okay, there's clearly a trend here. It's maybe not exactly linear, but it's like, it wouldn't be crazy to model it as a linear thing. There's also, there's also other types of models. So I'll show quickly how to do some of those. Yeah, so, okay. So there's a couple things here. First, I'll show an example of the sort of most basic type of forecasting you would do. And then this is, I wanted to end with some Python stuff because this is a good example, in my opinion, of like one of the gaps that is still available to fill, put generously. So yeah, what's the best way to do this? Okay, I'll explain as I go. Yeah, so right now, there are not super great tools for doing this kind of like forecasting, predicting type of stuff in Clojure. It's all possible, but it can be a little bit cumbersome, and this isn't necessarily the best way to do it, but I'm just going to show like what it looks like now, again, in like among the most verbose possible ways, just so I can explain as I'm going. So just jumping back to that tunnel data set for a second, because it's a lot simpler. To forecast out, so yeah, basically we need to extend this data set beyond what we have. So we have these days and we want to add more days on the end. And then we want to fill in the number of vehicles, the values in this column using our model. So like in some ecosystems like Python, that's pretty easy to do. There's going to be a few more steps for us. So if we say we want to predict 100 days into the future, We have to generate those days. Luckily, like this is something that's really elegant and cool in Clojure. I can just do this plus days. So I'm going to add one day to starting with our last day. And then this is going to return me like a sort of, ooh, right. Plus, sorry. This is going to return me like kind of a generator. Okay. I'll show it in the REPL for now. So, and what we want is to just take like a certain number of ones off of this generator. So let's see, why is it frozen? Don't fail me now, we're so close. I think it's just, there's just a lot going on. Now I'm nervous about the Python stuff. Okay, yeah, it's because it's trying to print them, sorry. So, right. Sorry, that was kind of dumb. But yeah, so okay, if we take just 100 of these, this will work. And this is gonna, so iterate is, I guess everybody knows what iterate is, or if you don't, you should check it out. But this is gonna generate us like stepwise a collection of days. And so now we can use this, we have to kind of piece it together ourselves as a thing. So we can start with our tunnel with the time dummy, but then we are going to, so I'll show this first. So we can generate a new data set using these like forecasted days and just an empty column for the number of vehicles. And then I'm going to concatenate it onto, so concat is how you like append rows to a data set, and append is going to append columns. So concat works here because we have the same columns. And I think actually this is risky, going rogue. But yeah, so when we're concating, it's going to just assume that we've got like empty values there. So anyway, we can then add our like trend column here. Oops. So this is just going to add that time thing. And then in order to, for the sake of the plot, I'm going to add a column that just flags basically whether this date is in the past or the future, according, like you might call them like real or projected, I guess, or something like that. But anyway, this is just so that we can, so I can show you something cool about how our API is intended to work. So again, this is just like our base plot where we tell it X, Y, and a couple other things. Then we'll add our points, and that's going to get us back to this tunnel traffic thing. So, and we've got, again here, so now you can see there's like some missing days. And if we now plot our smooth layer, so this is going to do, again, the regression for us and add the line to the graph. So this is super exciting to me. We can tell it to group the fields by this relative time column that we added. And then it should give us this kind of chart where we've got like past values, predicted values going forward, and sorted by color. So that's the idea. This kind of API is what we're going for, and the goal. So again, like this is obviously, this works, but this is very experimental. This Hannah namespace is actually like literally in this project. So this is something that we're working on tightening up. Okay. Lastly, I want to just go over a quick example of how you would do higher order models. And so, because, so for example, yeah, if we go back to this, this average sales thing, here it's like, you might say this is linear, or you might be like, oh, that kind of looks like some other type of higher order thing. If you wanted to like try that out, there's a couple ways. So you can do it in Clojure. So I'm gonna skip ahead and just, I'll explain this as we go. You can, so this is the tunnel forecasting thing. It's all the same except for here, these lines. So if we go here, this, we add our projected days, and then we add our trend. And then if you wanted to, you could do this manually. So you can say like, here's our trend squared, here's our trend cubed. And then if we model the, if we model the data as, I gotta get rid of the width, like, if we try to fit like a cubic feature or a squared trend to the data, you can get these like different types of fits or whatever. And like, so behind the scenes, this is using that computed squared value to like do the modeling. So this is possible. So again, like this is the thing is like, this is just not exactly how it's done. There's some more complicated stuff. And if you're a statistician, you're probably like, oh, what are you doing? But like, yeah, so just for now, I'll say like, this is a dramatic oversimplification of how you would compute these. And so there are some libraries that are available in, I will just say, other ecosystems, which, I don't know if this is going to work. Yes. By which I mean Python, to do this kind of stuff. So to end, the last thing I want to go over, and I'm super excited that we got this far, is just a quick example of how you could take advantage of some of these libraries from Clojure. So this is like, there's lots of other things. I mean, honestly, there's not that many. There's not that many that we're missing. There's not that much stuff that we don't have, but it's like, there's some very niche like chemistry libraries or whatever in Python that you might want to take advantage of. This is another very niche one. I mean, it's not super niche, but anyway. Called stats models. So stats models is a Python library that does exactly what it says, has a bunch of like great statistical models available, and I will show you how to use it from Clojure today. So I know the first question everybody has is like, don't make me use Python. In the repo for this workshop, so I'll share this after, there's a repo, and there's this notebook, and there's a README here. So yeah, so it's not always like the most trivial to get a functioning Python environment working, but there's some instructions here and some recommended steps to take to get Python running in such a way that it will be able to communicate with Clojure. So it's not super complicated. It's just a question of this kind of thing. You have to set up the paths to your Python executable and Python library in the right place, basically. So it's not like anything super scary. It's not anything crazy. I recommend using Conda so that you can have these like separate sort of dependency environments. And there's a file in here that has like the specific versions of stuff that work for this workshop. So anyway, it's not too bad, is all I'm trying to say. It's not the worst. It's not too scary. Or maybe you love Python. Maybe you don't have any problems getting Python environments working on your machine, in which case I'm super jealous and envious, and I want to learn how to do it. So anyway, yeah, so to do this kind of things, to do this kind of like, basically this is all we're going for. It's just going to generate these in a better way, these higher order trends. We are going to use the deterministic process thing. So I should have this up, but this one. So this is a Python class and it needs an index. And so this is partly why I hate object-oriented languages. An index is just a list of things, except it's not in this world. It's a very specific thing that has more complicated behaviors than just a list, but really it's just a list of things. And so we have to make our list into the right kind of list so that it can communicate with Python stuff. So yeah, so really, okay, so we'll start with this. Yeah, I'll show you. Okay, so basically we'll start with the average sales date column. So okay. I'm just waffling about how much to explain. So the average sales data set. Whoa. Right. Oh my gosh. Is this. And so these dates, if we do, oh my gosh, what? This should work. I've gone a little too crazy here. Yeah. Okay, never mind. Everything's fine. This is not super helpful, but anyway, the average sales, this is what I'm looking for, is like a specific date type. So packed local date is like a dtype next thing, and it's how they make dates like basically fast and efficient to work with. But obviously that's not gonna play well with the Python world of stuff. And so we're going to convert it to strings first, and then this is, I think it's convert types. So yeah, if we start with this time index, okay, we've got, yeah, just our date column, but now these dates are strings, not like any specific Clojure date type of thing. And then, yeah, I need to basically get this thing as like just a plain list of stuff. So I'll show you, like, basically what I'm trying to create is a pandas index. So to work, so this is the kind of key thing, I guess, to work with these Python libraries in Clojure, you can just import them. So this require Python thing is a function that's imported from libpython CLJ. So this is the library. And it does this kind of all this magic stuff behind the scenes that lets you import literally a Python module and work with it almost like it's a Clojure namespace. So like here, I've got pandas. And if you've worked with pandas before, like this would literally be like pandas to date time. And this is what I'm working with. So what we want to do, pandas to date time, and it even shows you here, like it's super magical. And this is Chris Nuremberger's work, largely. So anyway, we got to pass it just like a plain list, so a plain vector. So it's not going to be like a tablecloth column. It's not going to be any sort of Java object. It's just going to be a plain list of things. And then I'm going to tell it what the format of those is. And so it's going to be this kind of thing. And so if we run this, we should be able to see, maybe my connection is broken. Okay, whatever. So this is now a datetime index. So this is like a pandas Python thing that we're working with. And so now that I have one of those, I can turn it into a period index because, again, this whole thing where like you have these parochial like structures for data. This is like a Python thing and thing that's like super common in many languages that we just like totally take for granted in Clojure that we don't have. So like in Clojure, you have a list, and I guess to be fair, a tablecloth column is a special list, but it still behaves like a list is the thing. You could pass it around anywhere you could pass a list. In this case, we cannot. So we have to turn our datetime index into a pandas period index specifically, because that is what the deterministic process thing that we're trying to make expects. And so this is the equivalent of like instantiating a new period index thing in Python. So I'm going to do this, and I'll show you what that looks like. I've lost my like automatic updating here, which is a minor bummer, but I'll show you here. So yeah, so this is, I guess this is because the data set's pretty big, but anyway, this is now this period index, and now we can make the thing. So the deterministic process is like a class in this library. So I'm gonna just like go ahead, and this is what I find like pretty cool. And you pass it arguments like this. So again, looking at here, like this is the signature for it. So we've got like our new one, the index, and then this syntax in Python means like the rest of these are named arguments. And so for named arguments, we'll do it this way. It's like keyword arguments. So we'll tell it to make like a third order thing. This is I knew I would misspell it. I'm gonna copy some of this and skip showing every single one because it's usually pretty fast, but I think something about streaming is things are running slower than normal, and I don't want to hold everyone up. So anyway, so this is now just like a Python object. So now we're working with this Python object through this Clojure bridge, and now we can do stuff with it. So to use this, the whole reason you would do this is to generate these like data sets and forecasts. So if I do this, basically, so if I tell it to generate one, oh right, I gotta get my Python. So this is how you call a Python function on a Python object. So it's like very similar to the Java interop. So this is equivalent to calling like this in Python. And this is going to give us just a list of, a list of values that are based on the index. So it's like, it takes just the time column that we were working with, and it's going to generate our like trend and trend squared and trend cubed, in this case, columns for us. So yeah, this is a super bummer. It's really normally not that slow, but I'm too scared to restart things because I don't know what's going on and I don't want it to totally break. But given this is not really working, I'm just going to paste this here and I'll explain it, and then I'll just run it once at the end so it's not so slow. So basically, yeah, so we can do this in sample thing. This would generate us, eventually it will work, the sort of index, the trend squared, trend cubed, all the way up to however high of an order you set here. And then this is the magic part where it generates the forecasted value. So you can say, based on the index I gave you, generate me a certain number of like rows that are in sample, and then based on that sort of like thing, generate me 180 rows that are out of sample. Then there's some stuff going on here that you basically have to like piece it all back together. So this utility thing is just how I convert these pandas data frames back into tablecloth datasets. Then we're gonna convert the dates to strings so that I can join them up, because this, oh, sorry, I know what's going on. I just didn't, right. Sorry. So, okay. Okay, I'm just gonna, but anyway, I'm just gonna wrap up here. So anyway, so this is right. This is what it looks like. This is our in sample thing. So these are like the actual dates and the actual trends. And then we've got the trend squared and trend cubed. If we were to look at the forecasted one, it would look very similar, except it's going to like keep projecting out, and it's going to sort of magically do this, accounting for all of these sort of like edge cases and weird considerations that you need to take into account when you're generating future dates. And then this is basically just putting back together the data set. So if we think this is potentially a bad idea, but yeah, okay. This is putting it back together with the data sets. I'm just gonna go for it and try restarting this. There's some stray processes going on. This happens sometimes, and I know this doesn't bode well. But yeah, anyway, basically, this is this is our in sample data set. This is the model that we're going to train. So it's just going to be like a super basic linear regression model. This is the forecasted data set. So taking that forecasted trend pandas data frame, converting it to a tablecloth data set, and then adding on the original data set. But we're going to sort it by the time. Then here we'll add our predictions, and then I think this will probably work just fine now. Yeah, so like from here, we've got so basically we end up with this. So we end up with like the date, the trend. So these trend square, trend cube things were generated by the deterministic process Python thing. Then we concat it back to our original data set. So we've got a bunch of rows at the bottom with no average sales. And then we use the model to fill in the predictions. And so in this case, they are predictions for the future ones. Some people call it trends, some people call it, model, whatever. And anyway, then we can take this and just plot it like before. And that gives us this. So this is the sort of final thing. We've got our like trend line here generated by Python. It's projecting out into the future. There's all kinds of stuff you can do. You could use a different column. So like here we've used the like just the regular trend. You could use like the squared, what's it called in this one? Yeah, trend squared. One to sort of train and generate your model, in which case you would end up with, I'm gonna close this one. Whoa, sorry, okay, never mind. I'm not gonna wing it. Sorry, I know what Yeah. Okay, anyway, I'm going to leave it there. This is the idea. Basically, the point is to just show this sort of like, this is more like the important part, the Python stuff here and how you can interact with it. This whole notebook, again, like I said, is available if you were interested in following along at your own pace. Oh, right. And yeah, I guess I'll leave it there.